So before we start diving into some code, let's do a brief overview of what's Spark all about. What's it for? Who uses it? Why is it so popular? Why is it so hot? Let's explore. All right, so let's do a little introduction to Spark. What's it all about? What's the big deal? Well, according to Apache on their website, they say Spark is a fast and general engine for large-scale data processing, and that's actually a really good summary of what it's all about. If you have a really massive data set that can represent anything, web logs, genomics data, you name it, Spark can slice and dice that data up. It can distribute the processing amongst a huge cluster of computers and take a data analysis problem that's just too big to run on one machine and divide it and conquer it by splitting it up amongst multiple machines. And the way that it scales it is it can run on top of a cluster manager. So your actual Spark scripts are just everyday scripts written in Python or Java or Scala, and they behave just like any other script. Your driver program is what we call it, and it will run on your desktop or on one master node of your cluster, and it behaves just like any other script. But under the hood, when you run it, Spark knows how to take the work and actually farm it out to different computers on your cluster or different CPUs on your same machine even. So Spark can actually run on top of different cluster managers. It has its own built-in cluster manager that you can use by default. But if you have access to a Hadoop cluster, there's a component of Hadoop called Yarn that Spark can also run on top of to distribute work amongst a huge Hadoop cluster if you have one available. For example, you can use Amazon's Elastic MapReduce service to get cheap and easy access to a Hadoop cluster, and we'll do that later on in this course. And that cluster manager will split up the work and coordinate it among various executors. So Spark will split up and create multiple executors per machine. Ideally you want one per CPU core. And it can do all the coordination using the cluster manager and also your driver program itself to farm out work and distribute it to different nodes and also give you fault tolerance. So if one of your executors goes down, it can recover without actually stopping your entire job and making you start it all over. So the beauty of it is that it scales out to an entire cluster of computers. It gives you horizontal partitioning, horizontal scalability, which basically the sky's the limit. But from a user standpoint, from a developer standpoint, it's all just one simple little program running on one computer that feels a lot like writing any other script. So that's kind of a nice aspect of Spark. Why do people use Spark? Well, it has a lot in common with MapReduce, really. It solves the same sorts of problems. So why are people using Spark instead of MapReduce? MapReduce has been around a lot longer, and the ecosystem surrounding it and the tools surrounding it are more mature at this point. Well, one of the main reasons is that Spark is really fast. And on the Apache website, they claim that Hadoop MapReduce is 100 times slower than Spark in some cases, and 10 times faster on disk. Now, that's a little bit of hyperbole, to be honest. I mean, that's in a very contrived example. In my own experiments, if you compare some of the same tasks that we run on Spark to the same tasks that we run using MapReduce, it's not 100 times faster, maybe 2 to 3 times faster, but it's definitely faster. So it definitely has that going for it. And the way that it achieves that performance is by using what it calls a directed acyclic graph engine. The fancy thing about Spark is that it doesn't actually do anything until you actually ask it to deliver results. And at that point, it creates this graph of all the different steps that it needs to put together to actually achieve the results you want. And it does that in an optimal manner. So it can actually wait until it knows what you're asking for and then figure out the optimal path to answering the question that you want. It's also very hot. If you go to this web page here, it will give you a list of some known people that are using Spark. A lot of big companies are kind of secretive about what they're doing inside, so I'm sure there's even more people using it than what are listed here. But a lot of the big players are already using Spark: Amazon, eBay, NASA's Jet Propulsion Laboratory, Yahoo, and many others. The list isn't as long as MapReduce because Spark hasn't been around as long as MapReduce, but it's definitely gaining some big adoption quickly. And the beautiful thing about Spark is it's not that hard. It allows you to code in Python, Java, or Scala. So if you're already familiar in Python, you don't have to learn a new language. And from a developer standpoint, it's built around one main concept: the resilient distributed data set. There is one main kind of object that you will encounter in Spark over and over and over again, the RDD. And various operations on that resilient distributed data set will let you slice and dice and carve up that data and do what you want with it. So what would take Many lines of code and different functions in a MapReduce job can often be done in just one line and much more quickly and efficiently using Spark. So if you actually took my MapReduce course, we're going to be doing a lot of the exact same problems in this Spark course, and you might find it interesting how much simpler and how much easier those same problems are to solve in Spark compared to MapReduce in many cases. Spark is made up of many components. We're going to be focusing a lot on Spark Core, so just what can you do with these resilient distributed dataset objects, and how can you use that to distribute the processing of data and the mapping and reducing of large data sets. But on top of Spark Core, Spark also includes several libraries that run on top of it. So we have Spark Streaming, which actually gives you the ability to analyze real-time data streams, for example, from a set of web logs coming in from a fleet of web servers that need to be continually updated, and we'll talk about that later in the course. We have Spark SQL, which lets you run Spark on top of a Hive context and actually deal with structured data within Spark and actually run SQL queries on top of it. So if you're already familiar with SQL and you want to treat Spark as sort of a data warehouse, you can do that too. It also includes something called MLlib, which is a series of machine learning algorithms. And if you're going to be doing any sort of machine learning or data mining with Spark, it contains a lot of useful tools you can use to simplify a lot of common operations. For example, if you need to do Pearson correlation or get statistical properties of your data set, MLlib makes that very, very easy to do. And finally, we have GraphX. That's not, the kind of graphs where you're drawing on graph paper. It's actually managing graphs of information, network theory sort of stuff. So if you have a graph like, for example, a social graph of people that are friends with each other, things of that nature, or citations between documents and scholarly articles, things of that nature, GraphX can help you make sense of those sorts of networks and give you high-level information about the properties of those graphs. And that all runs on top of Spark Core. So Spark has a lot to offer, and it's expanding all the time. Now, people who are already familiar with Spark might say, why the heck are you using Python in this course? Well, yeah, I'm using Python as the scripting language that I'm going to be working with, and there's some pretty good reasons, so I want to kind of defend my choice here a little bit. Now, for one thing, it's a lot easier to get up and running with Python under Spark. You don't have to deal with dependencies and running Maven and figuring out how to get, jar files where they need to be and whatnot. Python, you just type your code. You don't have to compile it. It just runs, and that makes life a lot simpler. Really, I want to focus in this course on the concepts behind Spark and, how to deal with RDDs and what you can do with them and how you can put these different things together. And I don't really want to be focusing on things like, the mechanics of compiling and distributing jar files and dealing with Java and Scala stuff. It's just a lot quicker to get up and running. Also, there's probably a better chance that you're already familiar with Python as opposed to Scala, which is a newer language. And Java is just a little bit more complicated, like I said. However, I will say that Scala is the more popular choice with Spark, and that's because Spark is written in Scala. So if you write Scala code, it's native to Spark. It doesn't have to go through any sort of interpreter to sort of convert your Python code and get it running in a Scala environment. Now, I've never really run into problems with Python running on Spark, but in theory, Scala should be a little bit faster and a little bit more reliable. The other thing to consider is that new features and libraries tend to come out in Scala before they come out in other languages in Spark. A good case in point is the GraphX library that we just talked about today that only is available in Scala, but they're pretty far along in introducing support in Python and Java for GraphX right now, and by the time you are taking this course, there's a good chance it'll be available already. Similarly, with Spark Streaming, as of right now, that's only partially implemented in Python, but again, it's moving forward quickly, and I do believe that they will have feature parity among the three languages pretty quickly, so that shouldn't be too much of a concern going forward. Another reason that choosing Python isn't that bad of a choice for this course is that Python code in Spark looks a lot like Scala code in Spark. Even though they're very different languages from each other, within Spark, they look very much the same. They're both, use a lot of functional programming paradigms. We're using Lambda functions in Python as opposed to, the syntax in Scala for doing the same thing. But besides having to qualify some of our variables as being vals in Scala, where they're just untyped in Python, the code looks very, very similar in most cases. In fact, these two bits of code do exactly the same thing, and you can see the code actually looks extremely similar to each other. So even if you learn Spark using Python, it's not going to be hard to transfer that knowledge to Scala if you need to later on. So that's Spark at a very high level. What's the big deal about it? Why is it so fast? Why are people using it? It's pretty cool stuff, and it's very easy to use, it turns out. So let's, come down from the high level and get a little bit more technical. We're going to take a closer look at how Spark works under the hood and what the resilient distributed dataset object is. So let's do that next.